So we're playing a video, and the sound is coming out of the computer. It's being routed into the breadboard, and that is the input power, and then that's ground, and that's coming. I'll point with this thing, and this is going. See, this is the non-inverting op amp, right? You got this one to work, right? Mm-hmm. And that's the non-inverting input. That's the V plus input. The feedback, the source resistor has been changed with this potentiometer, and this is the same feedback resistor of 10K. And then the output, which was a 1K load to ground, is now being directed to that jack, which is then going to a fancy speaker I have over there. So the thing is, with having the potentiometer here, you can change the gain of the whole amplifier. And this is a 5K potentiometer, variable from 0 to 5K. You can take it all the way to 5K, because right, this is a 10K and this is 5K. And that gives it a gain of 2.
Right.
But because you can take this thing down to 0, you can do RF over R1 plus 1, you can get R1 to go close to 0, so you can get almost an infinite amount of gain. And so you can drive this thing into saturation. So that's where you're hitting the rails and you're flattening out the sine wave, which sounds like a great guitar sound. Yeah.
Is this how volume knobs work?
Yeah.
On your iPod and,
yeah.
and all that stuff?
Yeah, it could be how they do it. I mean, actually a lot of it's digital now, so I don't really know, but they...
At one point.
And a transistor radio, this could be how it works.
Yeah, you know, because on a transistor radio, if you turn it up real quick, you get that, or that could just be the static.
You get a lot of static in it.
Yeah.
Bang of the
you
speakers,
get that
yeah.
noise, right?
That's the noisy contact sometimes.
But that does remind me of a transistor radio.
It sounds a lot like it.
Yeah.
That sound, yeah. Yeah, so anyway, it's all experimental. Sorry it didn't work out so well today, but